Okay, so in this first problem, we're going to assume our data is normally distributed with mean 100 and a standard deviation of 10. So we want to go ahead and convert these z-scores to scores. So let's remember that by definition, the mean has a z-score of 0, so that's going to correspond with 100. Now each standard deviation is 10, so as I go up, one standard deviation away, it's just going to be 110. And then if I go up again, it's going to be 120. Up one more time, it'll be 130. And if we're going in the opposite direction, less than the mean, we're going to be subtracting 10. So 90, 80, and 70. So that's how you could do that first one. In the second problem, we were looking at using the 68, 95, 99.7 rule. So here, that says that within one standard deviation is going to be 68% of the data. Within two standard deviations will be 95% of the data, and within three standard deviations will be 99.7% of the data. So 68% of the scores here are going to be between one standard deviation away from the mean. So 68% will be between 90 and 100. So 95% will be between 80 and 120, and 99.7% will be between 70 and 130. Okay, in this next problem, we're going to want to go from data point to z-score. Here we can see that the data is normal with a mean of 25 and a standard 125 and a standard deviation of 30. So here our data point is 150. So we have this formula that says we take the data point, we subtract the mean from it, and we divide by the standard deviation. So here, let's turn our calculator on. That's going to be 150 minus 125, and then we're going to divide that by 30. And I set around to two decimal places, so that'd be 0.83. Okay, for our next data point, let's say we had 100. Well, here we're going to take 100 and we're going to subtract 125 and divide that by 30. All right. So we get z equals negative 0.83. So notice that this 100 is less than the average, so we have a negative z-score. Let's try one more. Let's try 80. So here we're going to take 80, subtract our mean, and then divide by our standard deviation. And this one we get z to equal negative 1.5. All right, so here we're going to use the same distribution, normal 125, 30, and we're going to say the upper 10% get a score of an A. And here we have a list of some scores. So to do this on the calculator, the first thing we want to do is go in and edit our list. So I'll go up here, let me clear out list 1. Okay, so I'm going to put in my scores. So 120, 80, 100, 115, 90, 100, 90 again, 112, 130, and 145. Okay, so here we put our numbers into the list. And now, okay, so in this next problem, we're going to have the same information that is normally distributed with a mean of 125 and a standard deviation of 30. If the upper 10% get a score of an A, it's going to want to find you the z-score cutoff. So let's remember that the upper 10% corresponds to the lower 90%. So our calculator is going to give us the lower 90%. So we're going to use the second vars and go down to option number 3, the inverse norm. Okay, and we're going to put in the area as 0.90. Again, we're going to look for the lower cutoff. All right, so, oops, I'm in my list. All right, let's go back. So again, second vars, inverse norm.